Welcome back to our brand knowledge channel. Today we are going to learn wonderful lesson on statistic, mainly on the topic of hypothesis, and we are going to learn two powerful hypothesis tool we are going to discuss. One is ANOVA, analysis of variance. One is two sample t-test or two sample tail test, right? We are going to do what is the difference, what is the p-value we are going to get it, and two software we are going to do it. One is Minitab, we are going to do it. At the same time, we are also going to do it in DATAtab also as well, right? Let's get started. This is my data set. Let me elaborate more detail what's the questions and all that. I have the questions being built in this way. I'll keep the survey link also in the description so that you can definitely follow. And I'm just going to the question. So this is the question. A quality team improvement is a quality team improvement is investigating whether the different approaches to document development yield different there is document development times. For 10 technical writers, the team measured the work that is in hour necessary to complete the finished document for each of the two different approaches. I mean, two different techniques or design, we can call it. Determine if there is any significant approach. So this is the data set. So A, B, C, D, these are all the technical writers, option A, option B, and we're going to do it in Minitab. And more importantly, it is coming from the book called, so this is the book, Joran Quality Book, 5th edition, page number 626. This question has been there. I will keep this link in the description also as well. And all of this navigation directly, I will do it in Minitab, right? So this is the data. I will just copy this data and I'll keep it in the Minitab. Okay. And what I can do is I can just go to stat and let's do first two sample t-tests, right? Two sample t-tests you can achieve through this basic statistic and two sample t-test. Determine whether the mean differ significantly between two group, right? Option A and option B, right? So I'm just keeping this particular one, and option one is this one. A sample one is option one, sample two is option two, and I will keep up for the both the graph. I'll keep it okay. And you can see that this is the box plot is given. Option A, it is taking minimum of 5 hours. And option B, that is taking 3.88. This is what box plot have to say. And then individual plot, if you see the values starting from here, and for example, all the way it goes here, and then option two is seems like quite significant. So we'll not get to know the significant by looking at the graph. So all you have to do is you have to go to the ANOVA table, right? So let's say this is the two sample t-test we are talking about. This is the mean 5.42 and 3.88, and standard deviation is this one. Standard error of mean is happen to be the same 0.33 and all that. And let me go. And the difference between these two is 1.45 hours. And the p value is very, very, very significant. So you can see the p value is 0.004. That is very, very less than 5%. It is this particular result is less than 1%. So therefore, it is very, very significant. That means technical writers options A and option B, if you calculate it, option B is found to have less hours of writing, right? Less hour it takes it. The same thing, let's say this is what we got the value, for example, 0.004. You all know 0.04 is less than 1%. So it is just, if you see here, it is just 0.4 percentage. 0.4 percentage is far smaller than 5%. So we are telling that it is significant. Both the values is significant. Okay. And then let's go to stat, ANOVA, and then the same exercise I'm going to do it. So one way, determine whether the mean of two or more group differs significantly. So I will keep this data and responses both. I will take option A and option B, and I can do a comparison. I will also will take the Tukey model also as well. I'll give okay. I will give okay. So this also has given this one, and particularly the same thing, ANOVA, analysis of variances. You can see here it has given that value, pretty much the same value what we got in two sample. 5.42 is the mean, and here we have got that 3.88, right? And then it also says that Tukey model with reference to zero where we are and all that. This is option A, and this is option 2 versus against the option A, right? It has also given that one. And let's see what the value we are getting in the session folder. So this is ANOVA. So ANOVA all means the null hypothesis statement all means are same. That means option A equal to option B, and option alternate hypothesis all, at least one mean is different. That means option A and B may be different. That's what we wanted to prove, right? So this is the one, and then you can see the p value is exactly the same, and then these two variable are quite weak correlation. And as you can see that the what is the 95% confidence intervals and all that, the very important topic which we were discussing is 0.004. That is the same answer we got in the other tool also as well, two sample t-test. So ANOVA gives a better option. So use ANOVA, because even for more than two also you can use. For example, you have option C, option third option, you have fourth option, you can definitely use ANOVA. So ANOVA has edge over than the two sample t-test. So same thing, what I'm doing it, I'm just going to create the same thing in the data tab also as well. I will take this data, and I will go to data tab. I'll keep the link in the description. So what I will do, I will just paste it here. So two options. So these two are metric, and you have a technical one. And what we are doing it now is directly hypothesis, right? So hypothesis test is here. You don't need to tell, automatically tool will pick up. So option A, option B, and then technical writer. And we'll keep that level of confidence 5%. And this is pretty much okay. And it gives that optional hypothesis statement, very beautiful. There is no significance between these two, and one must be having a different, right? And all that it has given the description, hypothesis statement, and then it also has given the value. And you can see, so it has also given the mean, among it has differentiated among the writer designs. And if I don't want that, I can also remove that also as well. So it came out, right? And maybe I will continue to keep that, and then I will go back. So very interestingly, what we are trying to find out is the p value, right? So p value, what I will do, as you can see here, because I'm just interested in those two metrics. So now what I will do, I will also ask for t-test, right? So this is option A and B. So t-test also I will ask for it. And then you can see here, this is the box plot it has given. And then it has given the Levin test. And it also has given that this one. So let's say I'm just considering this as a dependent one. Let's see the value. So pretty much almost closer to the same value what Minitab has given. So almost like 0.1%. 0.7 that has given 0.4%. So almost the same value. I hope you like this video. Please do like, share, subscribe my channel. You have one.